Hello everyone and welcome to this latest webinar from IHS Markit titled Driving Optical Network Efficiency Through Automation. Today our panel will explore the software architectures and applications that will enable automation in optical networks and see the results and lessons learned from early operator deployments in this area. Our webinar is co-presented by IHS Markit and our partners Fujitsu Network Communications, Juniper Networks, and Nokia. My name is Alan Tatara, Senior Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. So before we begin, I do want to highlight just some of the features available for you on our webinar and how you can make the most of your experience today. So the console that you're looking at is completely customizable. You can open, close, move, or even resize any of the windows that you have open on your screen and arrange the console as you wish. Now, at the bottom of your console, you're going to see a number of application widgets which contain additional features that are available for you. Make sure you check these out during the webinar. But one button I do want to call out is the resource list widget, and this is where you will find additional material about our topic, including the downloadable slide deck from today's session, as well as other valuable information, including a special report authored by our own analyst, Heidi Adams. And all these materials can be accessed and downloaded right from your console. And we do want to make this an interactive session, so we've included a Twitter widget. You'll see that at the bottom of your screen, and this means you'll be able to tweet right from the console. And today we are using the hashtag network automation. We will also have a live Q&A session directly after our presentation, so please remember to submit your questions or comments at any time by using that Q&A box that is on the left side of your screen. And if you encounter any technical issues during the webinar, just click on that question mark widget and you will get the answers that you need. So now let me introduce to you our panel. First, leading our discussion is Heidi Adams. Heidi is Senior Research Director in the Transport Networks segment at IHS Markit. Joining Heidi is Joe Christofic. Joe is the SDN NFV Solutions Planner at Fujitsu Network Communications. We are also joined by Domenico De Mola. Domenico is Vice President of Engineering at Juniper Networks. And rounding out our panel, we have Dave Brown. Dave is a Senior Manager of Optical Network Product Marketing at Nokia. So welcome to our panel. We are honored to have you with us today. So Heidi, let's get started with our presentation. So I will turn it over to you.
Great, thank you, Alan, and a warm welcome to everyone joining us for our webinar today. Over the next hour, we'll be exploring some of the opportunities and challenges ahead with the introduction of SDN and automation into optical transport networks. So from an agenda point of view today, we'll start off setting a bit of context and sharing of some recent IHS Markit research in this area. We'll then turn over to our sponsors to walk us through challenges, new solutions, and some really interesting use case examples of transport network automation and SDN-enabled applications in action. As Alan mentioned, at the end of the session, we'll have time for Q&A, so if you have questions as we go along, please do enter them into that question box. All right, so let's get started with a high-level overview of automation and transport networks. When you think of automation outside of the context of networks, generally the first thing that comes to mind is assembly lines and manufacturing facilities. The objectives in that context are generally to remove manual tasks, speed up production, improve product quality. These very same concepts are now being examined in the context of just about every aspect of transport network operations, including network planning and configuration, network maintenance, resource management, and resource optimization. And of course, on the network services side, we're seeing a lot of activity around the use of automation to improve how we deliver services and how we manage them over the service lifecycle. Now, if you look at the other side of this chart and look at the overall networking environment and some of the broader drivers for automation, we've got scale, complexity, and this need for agility. And these three things are really affecting every aspect of network operations. So you can look at scale in terms of increasing the number of endpoints in the network, the number of service instances, service capacity in and of itself. You've got complexity in terms of more complex mesh network architectures. We've got network slicing coming. We'll have to be able to manage SLAs within those slices. We've got real-time spectrum management, resource management, many, many things from adding additional complexity into our networks. Agility is from the perspective of looking at the network and its need to increasingly become and adapt to the requirements of more dynamic workloads and applications. So if you wrap this all together, initially automation was seen by many as a tool for reducing the cost of network operations, but we're starting to get to a point where automation becomes just a foundational capability and arguably is required just for sheer survival and basic network operations moving forward. So I'd like to share just this comment. I call it a word to the wise, and it's a great quote that came from Bill Gates with respect to automation. Automation applied to an inefficient operation magnifies inefficiency. Not so great. Automation applied to an efficient operation magnifies that efficiency. So key takeaway here is there's a strong need to simplify first in terms of our processes and workflows, then work towards automation. Thought that was an interesting quote. Keep that in the back of your mind. So let's have a linkage, or have a look at the linkage between simplification, automation, and software-defined networking. So here in this chart, I've got some results from a recent survey conducted by IHS Markit, where we asked service providers what they saw as the key drivers for SDN in transport networks. The top priorities that emerged were improving network efficiency, simplification and/or automation of service provisioning on transport networks, and also the simplification and automation of network capacity planning. So these tie back into that chart I shared a little bit earlier. This is right along those lines. So fundamentally, I believe SDN is a key enabler for driving network automation into the network. So from that same survey, we had another question that explored what are the key ingredients or the foundational technical requirements for introducing SDN into transport networks. And the list here, familiar list, you've been hearing a lot about this in discussions within industry. We've got the need for open APIs, and that's between controllers and the network equipment, between controller and hierarchical controllers, up into the business applications, and back and forth. So we see a lot of this. We see the need for advanced SDN-enabled applications. That could be things such as network health applications, real-time topology views, and centralized path computation. There's many, many in this area. There's also strong interest in SDN, not just for optical transport networks, but also for multi-layer and multi-vendor networks. So it becomes really the foundation for enabling the simplified, automated service delivery across diverse networks that may also be operated by multiple carriers for the delivery of multinational enterprise connectivity services, as an example. And we saw actually quite interesting a couple weeks back at the recent MEF 18 event, lots of examples of these types of technologies and concepts being applied into proof of concepts. And there has been a ton of progress made over the past year in terms of the sophistication of the solutions that are being brought to market. All right, so bringing all this together and building out a little bit of a broader view of the key trends in networking today, we can see in this diagram on digital transformation some of those elements we've just discussed. So you've got network simplification, you've got SDN and NFE as enablers of automation. We, of course, are now adding in analytics and coming out with new artificial intelligence, machine learning type algorithms that when put into a closed loop feedback type environment also serve to further enable and accelerate automation. And all of this, of course, is efforts supporting the broader migration of enterprises and service providers towards a broader digital transformation within their businesses. So that's a little bit of the overall context. So with that behind us, let's have a look at what we're going to be exploring today. Through the next little bit, we'll be exploring some of the new technologies, some of the emerging software architectures and applications that are going to provide this foundation for moving forward towards introducing increasing automation within optical networks. So with that, I'd like to hand over to Dave Brown, who's going to kick us off with a look at some of the challenges ahead. Dave?
Okay, Heidi, thanks. So, thank you. So, as Heidi mentioned earlier, there's some broader drivers here involved with this transformation in terms of scale. complexity and agility, and she just talked about digital transformation, and really that's what we see as kind of the overall overriding challenge that service providers are under pressure to do, and it's really all about going digital. And what we really mean by that is that we live in a digital world, and our networks are going to play a key role in that. And by that we mean that networks have to respond almost instantaneously with ultra-low latency and flexible capacity to meet shifts in demand, and provide mission-critical service reliability. And that's even going to be more critical as these 5G and IoT services play. And because of that, today's closed and static networks that are operated by manual processes just don't cut it. So, with that, network operators really have to do this digital transformation, and with that, they're building intelligent and automated networks to meet these needs. And with that, that's why we're building these open, programmable SDN networks. And they're really just the means to instruct the physical and virtual network to do the tasks and take the actions that are needed. But what they really need, and what we're going to talk about, is they need machine learning and analytics to determine or advise what those actions are and what they need to happen when they need to happen. So, I'll be talking about some network health analytics and optimization apps that can just do just that. So that's kind of just a look at kind of the overall challenges and bigger picture on how they're tackling these needs to reduce revenue and increase the revenues and reduce OPEX and optimize CAPEX in that. So that I'll turn it over to Joe.
Thanks, Dave. So what I'd like to get into as a key theme here is operationalizing the open and programmable network. So we'll talk a lot about the open models and APIs and automation today. And one of the key focus areas is how do we operationalize and how do operators deploy these networks during their network modernizations. And some of the key driving forces there are speeding up adoption of your optical network, and then on the northbound side, increasing the velocity for revenue generation and services that you can build over this new network. And so those are that's a key theme for operationalizing the network. And some of the key components within that as sub-challenges to the network operators are how do we deploy open models that we're talking about, integrating with APIs, connecting control data from the network and leverage that data with analytics and AI, machine learning to improve network efficiencies. And then we'll talk a bit about network or software architecture and how are we delivering software in this network modernization with open technologies to deliver software faster than our traditional monolithic deployment model. So those are some of the key challenges that we're looking at and we'll address today in our discussion. And with that, I'll hand it over to Domenico.
Hey, thanks, Joe. Let me say, we can agree more with what has been already stated by the team. And so just to recap a few highlights, SDN has emerged as the enabling architecture or technology to address network operation needs for automation and their priority for operational agility and rapid service deployments. And greatest benefit will come from integrated and multi-layer solution, as Heidi stated, in packet optical networking. In the next slide, we will have some area of focus. Openness definitely is the mainstream, the main role. And we look at optical line system architecture, what's coming new on the market, however, introduction of open and multi-vendor terminal, traditionally called transponder, but also new requirement for vendor agnostic design, simulation, planning tools. Programmability is programmability. So we want to program the network instantaneously, faster, more efficient. Common Open API is the opening the door toward a network that is programmable. Integrated telemetry will complement, and the direction is multi-layer controller. But what customers are looking for is simplification. They want a simple and simplicity out of their network. while the complexity is growing and overall. So automation in workflow is the answer we need to cope, and we need to address into the next slide, but also a way to optimize the infrastructure, whether software and hardware, by sharing across the different layers, different functionality, and different operation workflow. And the end is an end-to-end management of services and infrastructure. And with this one, Heidi, back to you.
Heidi, I think we'll turn it back to you.
Thank you. So that was a quick look at the problems and challenges. I'd now like to flip over to having a deeper look at some of the new options, technologies, and solutions emerging, and we'll start off with Domenico to kick us off. Domenico?
Hey, thanks, Heidi. Thanks for the assist. So let's give a look to most relevant SDN architecture that we do see on the market by double-clicking and focus on the optical networking on transport networking. We do see three major optional definitions forthcoming on the market. The first one is the traditional optical system vendor architecture, where we can define vertical integration. And one of the key attributes is operational simplicity, when, of course, is operated in island. It's based on a traditional EMS or element manager for device and network element management, and in the new generation can expose an open common API, northbound, for integration into an hierarchical controller or an orchestrator. However, most are legacy type of EMS, and so they don't have a native standardized YANG model, so a translation into the model is needed, and this can increase the complexity and integration challenges. Those networks are typically built for best performances, at, of course, at cost of price. They are vendor lock-in, which is something that a network operator are looking to escape from, and as I said, they provide an open northbound interface. The evolution in the modern SDN architecture is the transformation of the role of the EMS into an optical controller, an open optical controller, and go with the partial disaggregation. We define this type of architecture as an open line system. Of course, it enables separation and disaggregation of the electro-optical terminal transponder from the optical line system, which can be supplied by a different optical vendor, and enable integration via multiple API northbound with a mix of device and networking models, which is, by the way, a challenge because the orchestrator has to interpret now different behavior and characteristics. So while this is a step forward, you can end up with an over-engineered network. However, the controller can represent a more traditional operational model. You can use the controller on behalf of the EMS, and it enables, as we said, fast adoption of the latest technology, and through vendor competition, why not reduce CapEx, where network operators are always looking for. But to conclude and foster the highest operational agility, it's critical the transformation toward a true open and disaggregated architecture. And the key attribute is a single software controller to integrate the different domains, whether it's device, whether it's node element, or different element of a network belonging to different islands, and expose everything via a single northbound API interface to abstract, to model the network functionality. That's the level of simplification that customers are looking for. And on top, it will provide some trade-off in terms of cost and performances. You can always select the best suppliers, and beyond the traditional optical vendor, you can enable a new generation of supplier, which is the innovator that are in the supply chain of the optical domain. Automation and simplification via a unified northbound API. Going to the next slide. Indeed, what we have learned about openness and disaggregation, which benefit the customer and their workflow automation. Multi-vendor solution is a key enabler to have open and agnostic design simulation planning tool, and a standardization toward a common model for device and element in the network representation. Programmability of a multi-layer for performance optimization end-to-end with real-time telemetry across different network layers and a standardization of building blocks, whether hardware building blocks or whether software building blocks. And a simplification via network automation or via workflow automation with being vendor independent and with a single pane of glass in network operation. To the last slide. As we said, the key building block for an SDN transformation of a network is a multi-domain controller. And just for clarity, it's about a software domain, not just or only networking domain. And the critical is the software transformation of this architecture. It's required to the controller to be flexible, to provide flexibility in order that we can integrate the different open common YANG models from southbound. Then we will have a variety of this YANG model, and we need to be ready to seamlessly integrate into the controller for device element management. It will be required to have enough smartness to orchestrate and integrate process and services that will run into the controller and be able to export the added value to northbound where automation is required and agility and simplification is required. So we need to extract the value for the customer, avoiding to provide them the complexity of the management of this architecture. And it is required, of course, capabilities to interact with different new environment or ecosystem or external application that will arrive on the market. And there are a few examples. Telecom Infra Project is one, Open ROADM ecosystem, and probably many other ecosystems will rise towards the horizon. Some of the key attributes, of course, are standard common API for device and controller model, and the capability to onboard via the same API third-party application of microservices. Programmability in multi-layer via integration of via real-time integration of a packet and optical control plane, and integration of path computational element, packet and optical, and orchestration via multi-layer optimization tool, whether offline and real-time. Simplification of the software infrastructure via microservices architecture, deployment in independent container of these microservices, and the simplified operation will provide the scale out that network operators are requiring at no anticipated cost in terms of software infrastructure, and via Kubernetes environment orchestration, load balancing, and scheduling will provide a simplified operational model for the controller. And with this one, I will pass to Dave.
Okay, thanks, Domenico. So I'm going to just take a look here and review where we've been and where we're going and how we're going to get there. Expect automation, and then look at some specific automation apps. So here, and again, as mentioned, the networks need to go digital. So we've got this digital transformation from closed and proprietary manual operations toward a new paradigm of fully automated and open networks. And so the first step here is to get your network transformed by employing open and agile hardware that supports multi-vendor interoperability, open management, control interfaces. But that's just the foundation, because there's still a tremendous amount of work that needs to be done to take advantage of that agility and openness to increase your revenue and lower costs. So with that, the next step is then to introduce these standard open interfaces and models that are now becoming available, such as TAPI and BIG, and then also with open automation applications there. So with that, now we're at a point where you can leverage these apps they're designed to automate, monetize, and network in an open and multi-vendor environment. So let's look at closer at some of these apps. These are just examples of some of the emerging network insight automation apps, as we call them. And they range from reactive network health monitoring apps using streaming telemetry agents to more proactive planning and analytics that come with sophisticated machine learning-based algorithms. And then there's optimization apps where you can optimize network link channels. So if we look just a little deeper at those here on this next slide, so these, as I mentioned, these network insight applications use real-time network intelligence to help you make smarter business and operational and structure decisions. And they combine automation algorithms with analytics to maximize the performance of fiber optic links and channels. They let you select different levels of learning and automation so that you can address your own operational environmental needs. So you can employ these independently or in combination, but when you deploy them together in a closed-loop system, as we have depicted here, it's really going to enable you to extract maximum capacity from your network and monetize this capacity instantly and deploy services, equipment that supports those services more. So now let's take a look a little closer at the at Health and Analytics app. These apps can, what they do is they collect, visualize, and analyze data in your network. And they do this by using streaming telemetry, looking at historical big data records, use performance monitoring, trending analyses, prediction, and machine learning, as I mentioned, to analyze and predict network behavior and then monitor network health. So this particular app actually performs reactive network health monitoring of KPIs like spec BER and power to detect anomalies in terms of thresholds that you have against these KPIs and any baseline deviations from those, as well as proactive analysis of KPI trends, the rate of deterioration in your network, and any anomaly predictions of these KPI behavior. So that's a little closer look at Health and Analytics. The next slide, we'll look a little closer at the Optimization Network Insight app. The optimization apps, they assure optimal transport network performance, capacity, and resource consumption, and it's based on current and future optical transmission performance indicators. So this enables dynamic adjustment of programmable network capabilities. So that's where the programmability and open SDN aspects come in. And it supports adjustments based on measured transmission parameters and past wavelength performance rather than designing the network with traditional and these adjustments are triggered either by threshold crossing alarms or notifications from the Health and Analytics apps or from periodic scheduled notifications that you program in. So these emerging optimization apps enable the capability to optimize links and channels and take advantage of programmable modulation formats and margins that you get with advanced. So that we'll turn it back to the next presenter.
All right, thanks, Dave. So we see our direction in the industry moving towards open networks and open architectures and leveraging this throughout the network stack. We're coming from a place with closed networks, vendor systems, and very close, tight, coupled integration. And so the reality is, as we move in a direction, we'll have a hybrid world. And so we'll be able to leverage models and APIs that begin to come out in the market and build our hybrid world through open line system, leveraging open ROTA models, open config at the transport layer, and how do we deploy that, operationalize it so we can realize the benefits as we move towards the directionally in the open networking space. So we've got models and APIs to consider, connecting and controlling, managing and automating that world, and then how do we deliver the software components from our controller and orchestration perspective to manage that hybrid world. You know, the reality is that we have legacy systems in place, we have investment in the transport space that we need to take advantage of as we move forward, but we need to be deploying with the mind of moving forward to open networks. So it's bridging that those two worlds together. So we need to look at some of the ability to do that with architecturally and how we prioritize that effort. So just digging a little bit deeper into that discussion, while we support our legacy northbound, our closed systems, we can look at leveraging domain controllers and orchestration systems through open APIs northbound to streamline that transition, and then southbound begin to implement our open models, open ROADM and open config, which we've discussed at the network services layer and network management perspective, and bringing that integration together to migrate from our legacy systems and deploy and start to seed that network in the transport space. And so along that way, we have to bridge the gap between some of those areas that may not be available in an open models or open networking for specific carrier environments that we need to address, and gap filler solutions to piece together that open networking story as we get to that realized vision that we saw on the previous slide. It requires detailed integration and design considerations as we move there, and some of that we'll get into on the following slides with how we deliver from a software perspective. Some of the focus areas we need to be mindful of in moving towards these open programmable networks is we still need to maintain our end-to-end connectivity and provisioning concept, service activation, network management, automated assurance, and analytics on the network. So these are some of the pillars to build your open networking and to really focus on this. And then within each of those categories, be looking into the APIs available, the ways to abstract this information from the network, and be able to leverage it with new technologies to ultimately deliver more services more efficiently and add new revenue generating services over this new modernized network. One of the key concepts we've discussed a little bit previously, but is disaggregating this world. So now that we're looking at components of the network in open and models with APIs and breaking it down into data sets, we need to disaggregate it, whether it's your physical network elements, your virtual network elements, or the software components of it, the features of how software is working together, is disaggregating that and operationalizing the disaggregated pieces from a reaggregated approach at the higher layer of the network. And so we're starting to see some of that in how we break the network down and managing that from a higher level, all via open mindset as far as how we manage that network from a disaggregated concept. Okay. One of the software architectural shifts that we're beginning to see that will contribute to this modernization of the network, leveraging the models and APIs, is microapplications and microservices. So containerized software packages that are specific use case targeted driven, where we're moving away from the monolithic deployments of software platforms that are aggregating feature sets upon feature sets, and regression testing becomes lengthy. We need to get away from that mindset as we're trying to become more agile in supporting open networks via software. So in that shift, by moving to a containerized architecture, we can really refine on where we want to pinpoint our features on the network. And so when we have upgrades and new feature additions, we can seamlessly add that in a scalable model, leveraging Docker and Kubernetes in all of our network spaces. So whether it's management, control, our virtual functions, analytics, extracting the features of those components, breaking them down into microservices, and then reaggregating them in a concept of microapplications, we can program and control this network in an automated fashion. We've talked a lot about automation. Well, how do we automate the components of a network and be able to manage that automation effectively to scale at a global level? And so we'll see more discussion around microservices and how we can support networks from that perspective. And with that, I'll hand it off to Heidi. Thank you.
All right, so a good introduction to a lot of the new capabilities that are going to be enabled on our applications moving forward. And in this next part of the presentation, we're going to dig in a little bit deeper into some more real-world type use cases so you can see this technology in action. So to start us off, let's kick off with, I think we've got Domenico up next. Domenico?
Hey, thanks, Heidi. We are really partnering into this conversation. So we're heading to last part of this presentation, and we want to start to look at some practical use cases for implementation. We can effectively start with probably what I believe is one of the most important application, that is planning. A good plan is half of the endeavor. And as logic, you needed to try to learn from what you have access into the network and apply to predict, simulate what is going to happen. So data mining and extracting trending from the behavior of your network will help you to apply to your simulation some learning and drive some of the direction in terms of the implementation, efficiency, and the networking design. So you can do via an historic view of your performances and apply to the simulation tool, but also rely on optimization that are based on the new devices that you are introducing via birth certificate. The second important aspect after you have design and plan your network in the workflow automation is monitoring. And verify that what you have designed is effectively performing in that way is part of a real-time visualization. So you can look at where are congested packets or optical link, whether there are performance degradation, and you can look at into an holistic view what are the KPI that your network is providing as a return back. And this is how you improve the efficiency. And after, and the last is how you get to an optimized network. And there was a question, once you have centralized your controller, what you're going to do? Well, you can start to do optimization around your network. So you can apply and enforce policy from other application or other element of the network, and then you can start to program, for example, the capacity of your link based on specific SLA or specific quality of the set. And as an example, you can predict where are the high latency link and apply this policy, or where are your share this link group and apply protection policy to traffic that needs to have a priority and so forth. So that's the way we can apply in a very simple step and practical step to get the ball rolling, and then you can go toward more complex type of solution as autonomous network, machine learning, and so forth that Heidi has catched. And with this one, I will pass it to Dave.
Okay, thanks, Domenico. So, so now I'm going to take a closer look at some of the examples of the Network Insight apps that I talked about. So here, look at the Health and Analytics app and how that's actually being deployed. So as I mentioned, these Health and Analytics apps provide on-demand access to critical network performance information that's necessary to preempt problems and optimize resources and plan for maximum return on network investments. So as you can see in this sample GUI here for our tool, this tool gives you an end-to-end web-based visibility into geographically dispersed multi-vendor infrastructures. So it lets you monitor, analyze, manage, and predict the performance from a single centralized location, and then provides rapid analysis with an out-of-the-box and executive report. So, so it's using streaming telemetry here to basically collect, visualize, and analyze your network behavior. So that's a look at Analytics app. The next one is the Network Optimizer. So this is a sample of optimization tool GUI, and tough to see, but on the left there's a menu of different tools you can use here. Just a couple of those to highlight. One is basic link optimization application tool that assures optimal optical link performance, and that's based on current and future optical transmission performance indicators. The one we're actually showing here is a channel optimization app, and that enables dynamic adjustment of programmable wavelength modulation formats. It's according to measured transmission parameters and past wavelength performance rather than, as we mentioned before, designing the network with the traditional end-of-life parameters. So in this example, the customer here, he needs more bandwidth to support a new or growing service demand, but rather than waiting for deployment of extra capacity, you can optimize an existing wavelength channel using programmable modulation schemes. This is where the whole programmability of the network and your for instance, he can optimize this PL1 service that's there in the middle. And he can select to go from what's now 100 gig QPSK modulation scheme to up that to a 200 gig AQUAM. Or in another example here on the second service, CL1 service, with the newer PCS or probabilistic constellation shaping, which is an advanced super coherent technology, he can enable infinitely variable capacity. So he can optimize that service channel CL1. He can go from what's now 225 gig PCS service up to 305 gig PCS. So it really gives you a good, good tool to really optimize the channel. With that, I'll turn it to Joe.
All right, thank you. So I'd like to introduce some of the building blocks that we have for some of the applications I'll speak on in the following slides. But we have a focus on our orchestration layer with our Vitura SA offering, and then also integration into ONAP, where we have some illustrative industry use cases on ONAP integration. And then we have our network control layer along with our management components applications, and I'll speak a bit more about those components later on. And then southbound with our disaggregated blade approach into the transport optical space along with our switch blade, and we'll show some of that in the following application slides on how we build and operationalize a real use case leveraging our components here illustrated right here. So the first one, application being MEF17 proof of concept, Heidi talked about just a few weeks ago with the POCs that we saw in the industry at MEF. If we go back a year to MEF17, this POC was the Gold Award-winning POC, where we show integration and everything we've talked about today, where we've talked about open models and APIs and integration, analytics. This is all applied in an illustrative application here at this POC, where we did intercarrier E-line service orchestrated via 2 ONAP instances between 2 carriers. And the southbound component, we have Ventura suite of control and management controller, and then below that we delivered this solution over Open ROADM. So we did layer 2 service over the blade-based architecture with E-line service over Open ROADM using the Open ROADM models and service for the wavelength, and then northbound using API into ONAP, into the SDN controller and DCAE component for PM listening. And we talked about the microservice, and in this case, we delivered a microservice with DCAE engine and ONAP that was as a listener for that network utilization, where it's in a threshold notification crossing to the partner ONAP instance to increase service. So this is one example where we begin to see in the industry the models, the APIs, the disaggregated approach, the automation, the closed-loop automation all coming together as part of this POC. Following that up, just a few weeks ago at MEF 18, we have another example use case of leveraging the models, APIs, and integration work with a 5G fixed wireless access use case where we managed bandwidth customer service over a 5G infrastructure through a network edge cluster, northbound into ONAP as well, in this case, deploying a microservice to do that real-time analytics and a threshold crossing for that service profile over the 5G. So the switch would be from the wireline access that you see in the top gray box down to as the customer migrates from a fixed connection moving into a wireless fixed wireless access domain, that customer experience was seamless and all orchestrated via ONAP. So again, we see all of the components we've talked about today, operationalizing them into a POC type environment and leveraging open APIs, interfaces, models being deployed in this application. And I'll hand it over back to Heidi.
All right, so that wraps up some of the deployment applications. I'd like to give each one of our sponsors an opportunity just to showcase a little of the work they are in particularly doing in this area. So first off, Domenico.
Thanks, Heidi. Okay, so let's address the business and vendor hat and try to ask what is the ultimate question, which is the most efficient and effective SDN architecture. Well, I will turn, are your requirements of a simple, quasi-static, siloed traditional network, or are your requirement of automated, dynamically scalable, and operational agile network? Juniper is trying to answer with a focus on open, programmable, and simple to enable software solutions for management and orchestration over sources and services. And, of course, our openness to third-party integration. Juniper offers an end-to-end layer 3 to layer 1 product portfolio, enabling multi-layer integration via disaggregation and packet optical and open optical line system. In a nutshell, Juniper provides a networking solution that spans and integrates end-to-end from access and aggregation up to edge and core, and we support an integrated packet optical transport infrastructure and a single pane of glass for management and orchestration. And with this one, I thank you, and I pass to Gabe.
Okay, thanks. So here, just to wrap up what I've been talking about, we focused on what we call Nokia Wave Suite Network Insight applications, and these are really part of a bigger set or suite of open apps that we introduced back in MEF 18 a couple weeks ago. So the Nokia Wave Suite apps, they're really open applications for the network transformation we've been talking about, and they include service enablement apps, node automation apps, and then these network insight applications. And as I mentioned, the network insight apps are real-time closed-loop automated health and analytics and optimization apps. And they really harness the flexibility and programmability of our Nokia PSE3 DSP that has that PCS capability, that variable capacity and reach option that works with the 1830 PSS platform and then our NSP SDN controllers. And that helps provide this real-time visibility and analysis to optimize network resources and performance, and that network operators can really maximize the monetization and the ROI, their network infrastructure and the resources, which is really what these automation. That I'll it over to Joe.
All right, thank you. So breaking down the components for this, we've got our Vitura service activator solution doing the control orchestration across multi-domain. We also have our Vitura network controller doing the network control, service activation, path computation, protection, and restoration of transport network, as well as our layer 2 off packet. And vSure, our vSure application, providing the closed-loop automation for service on demand, elastic services, and then we also see our network management and NetAce. NetAce supporting heterogeneous network environments, including VNFs, our virtual network elements, and our physical network elements across in the cloud as well. And then we have our Onefinity product line, our blade-based approach that we can disaggregate from a physical network perspective and apply our software solutions that you see here. We also are integrating this into our AI and ML through conscious networking, so leveraging the capabilities of an AI and integrating that in to be able to build solutions over a network. And we introduce AI, ML with the conscious networking as well. All right. Thank you.
All right, so with that, we reached the conclusions. Just before I step in to wrap up the session, I want to encourage you to submit any questions you may have into that Q&A interface. So to wrap up some of the key takeaways you should have taken, hopefully, from the session today. Automation, very critical for managing scale and complexity, as we move forward in the evolution of transport networks. Also, we're starting to see the emergence of a more open, programmable, software-defined infrastructures being that foundation for enabling us to deliver A, more automation, but B, more applications that are going to facilitate management and operations, as well as service delivery in these networks moving forward. And finally, hopefully you've had some or picked up a few interesting points with respect to some of these new applications that are emerging, a very exciting area of networking today. So with that, I'd like to wrap up and move over to the Q&A section of our webinar today. And for that, I'm going to kick off with a little bit of a general question. So to our panelists, it looks like there are a lot of changes needed to the underlying network infrastructure in order to enable a lot of these cool new applications, be it network health or optimization or new ways of provisioning and delivering services. So we're curious, where are operators today with getting these foundational parts in place? And when do you expect to see some of these new applications becoming more broadly deployed in production networks? So maybe, Dave, I'll start with you. Any comments on this?
Yeah, it's a good question, and I guess what we're seeing is that over the last couple years, we think operators have been creating their network in this transformation, putting in higher capacity, the programmable modulation schemes with some of the current generation DSP and transponders. Also installing, flexible FlexGrid ROADMs and whatnot to just increase the flexibility and agility of the networks. And now they're starting to, trial and test out these open interfaces and the programmability of the controllers. Take advantage of all this. So
cool.
With that, then they'll start to introduce automation.
All right. Joe, are you seeing anything different in the customers that you're working with respect to their readiness to start enabling some of these new applications?
Yeah, I think we're seeing it, across the board, some adopting faster and deployment components of what we've talked about and operationalizing some of the models, whether it's service enablement, leveraging models into systems, or in certification labs, testing with trials. So we're seeing it, I think, across the board, and we'll begin to see more and more of it in the coming years.
Okay, Domenico, anything further you'd want to add into that?
Oh yeah, well, I think while the technology is becoming ready and there is more awareness, I do see now the push from the business perspective with real use cases like the Remote 5 application for cable operator, or the 5G announcement, or the transition to multi-cloud private to public architecture that are pushing a lot of traffic into the metro network. And so both the IT and the transport layer, they need to start to cope with this new reality, and many network operators will force a refreshing to their network. So the technology and the business demand will start to cross at a certain point in the next couple of years. That is the most exciting part of this conversation.
Okay, excellent. I've got another question here that I think is really quite interesting as well. One thing we didn't touch on in our discussion today was security. So as we look at introducing all these next-gen network capabilities, and as we start becoming more open in terms of our implementations, how do we ensure adequate security? Would any one of you guys like to tackle this question?
Well, I can take Heidi if you. Well, as you know, Juniper has a complete portfolio, not only in terms of IP and transport, but also as security. And it's going to be an end-to-end integration because it's not just about the firewall now, but with this virtualization and cloudification of a network, the security is not going to be localized, but is going to be ubiquitous into the network. So it's features of the network, as a matter of fact. We didn't spend time here, but it's definitely a critical element that will drive and force more of these automation integration to avoid the breaking into the network workflow.
All right. Okay, I'm going to turn it over to a little bit, just a little bit more of a business type question. So, we've heard a lot of discussion today with respect to disaggregation. So be it hardware from software, line systems from transponders, there's different models here. But we're also now starting to add in new requirements for integration that didn't really exist before, which in theory add costs. So the question is, has anyone looked at that overall TCO for these newer disaggregated systems and solutions? And is it really better at the end of the day? Or is this perhaps more about adding in network flexibility and agility, even if it costs a little bit more at the end of the day? So curious, have any of your companies sort of dug into this question at all?
Yeah, I'll go ahead and take that, Joe, here with Fujitsu. I think what you're seeing is, okay, there's a realization of moving towards these open programmable networks, but getting there, we have gaps. We have places where to operationalize, we need a focused effort on how we can integrate systems, network layer, and that's where we're starting to see adoption of microservice architecture and how we deliver software solutions that become more cost-effective in turning around our software support of networks faster and more rapidly. Trying to approach this new world of networking in an open manner and not having that, it does become costly to be able to manage that deployment. So I think we're starting to see that from a software perspective to support these type of networks. We need adaptable software architectures, and so from that perspective, that's one area I think we're starting to see it.
All right. Okay, well, I'll just, I think we're at the top of the hour. I'm going to wrap up the session today. So thank you so much to our panelists and to our audience for participating. I'd like to hand over to Alan to wrap us up.
Thank you, Heidi. I want to thank you for leading our discussion today, as well as our panel of Joe, Domenico, and Dave for sharing your expertise with us. And I want to thank everyone for participating on our webinar as well, and for submitting your questions and comments. We did receive a large number of questions, so our panel will be following up with you shortly. An archive version of this webinar will be made available shortly, so feel free to come back again, view this session, or perhaps even share it with your colleagues. And you will see a short survey pop up at the end of our webinar, so please take a few moments to fill that out. And also, please make sure to continue to follow us on Twitter and LinkedIn for future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.